All right, we're back in CH9 Live from TechEd Europe with a familiar face.
Yep.
Bart JF to Smet. How are you doing, man?
Very good. How about you?
Good. So you're close to home.
Yes, yeah. Belgium, just a couple of hours train ride.
Right on, man. Mm-hmm. And you're going to be there speaking to a user group at some point, or did you already do that?
User groups and going to Dublin, London.
Excellent. Yes. So this panel, not surprisingly, is, it's not a panel because it's you, but I guess the virtual audience will be the rest of the panel.
Yep.
RX, RC, RX 2.0 RC. We have an 80-minute interview on Channel 9.
Exactly.
I highly recommend you watch it. You'll learn a lot about time.
Yeah, it's all about time.
And other things.
And other things, yes.
And of course, you're linked to Everything Dream, and basically ask Bart whatever you want.
Yep.
So tweet questions to #CH9 Live. We got Bart to Smet here. Ask away. I know these guys are awake. We're in the same time zone.
Yes, yeah. Lots of the familiar faces. Yep.
In RX 2.0, RC, what was the biggest, what was the hardest problem you solved?
Everything that had to do with time, really. Yeah.
Okay.
So that was the thing that took most of the time, actually. Kind of pun intended here. Basically revising the way we did absolute time. So the way we dealt with absolute time was by doing subtractions of time and then converting it to relative time, which has all sorts of undesired side effects, including system clock change resiliency, things like clocks having different notions of time. So you didn't arrive early or you didn't arrive late, you arrived in an unpredictable fashion.
Yes.
And so centralizing all of that logic into a centralized timer queue was really what actually took the most tuning. It wasn't so much about the algorithm, it was more about how should we do this based on the data we have from the lab. In the lab we saw timers being off so many seconds a day at most, and what's the right thresholds, and there are some magic constants in there, right? When do you transition between one queue, the long-term queue to the short-term queue, those kind of things was more about running enough tests to actually get an idea of what's out there in the wild and how machines behave.
Sure. Yeah. So now, as I said, people can go deep and watch that interview. But I want to step back because you've gone so far down the rabbit hole, chasing the white rabbit in your implementation of RX, a lot of which you do personally. Step back out and tell me about what's the vision today of RX and LINQ, and what is the dream now?
Yeah. So let's maybe start with the RX aspect and then sort of extrapolate to the bigger LINQ aspect, right? So the thing to notice if you look at applications today is that they're in a totally different spot than they were say 5 years ago. Applications have to react to data coming into the application. Think about sensors, I did a demo here this week with Kinect. That's a totally event-driven system, and moreover the events carry useful information. They're really streams of data. Now in the past you were more in an interactive space where the application was saying, hey, I want to query this database, I want to walk up to SQL, and then start doing a loop over that to fill a data set or put that data set on a form. So it was more about pulling the data in. And so what's happened over the last, really number of years is that data has come into the application much more in a push-based event-driven fashion. Take a look at sensors, take a look at things like Twitter, Facebook, all those things basically push the data at you. And it may not be the case that all the underlying platform capabilities are there yet. For example, if you're doing Twitter, it's really based on long polling or doing some periodic timers. But the programming model that you want to be at as an end user is to process the events coming into the system as they are events. You don't want to have timers that poll something. You actually want to be in the place where you actually deal with observable sequences. And so we are basically reacting to that trend by sort of, putting a unified sauce on top of that, where you have all of those different kinds of event sources, including .NET events, WinRT events, sensor APIs, social media, server monitoring events, all of those things. You don't want to sit and wait for them to happen. You want to react when they come in.
Yes.
And so that's actually the inversion of the control in some sense, to which we need to build a library. And so that's what RX does by saying we abstract over all of this using observable sequences, and then we build a query layer on top of that. And the query layer is really what people are excited about, right? It's the ability to do things like throttling sequences, sampling them, doing analytics over sequences by chunking them up in fragments of time, doing rolling averages, over, for example, stock data. Like all of those things are basically LINQ, but on a different mode of getting the data. Like in the past it was enumerable based, today it's actually observable based. Well, it's not or, it's actually and. Like depending on the scenario, you want to be pull based or push based, or maybe something else. And that's where the LINQ to anything comes in. Like, why can't you, for example, use LINQ syntax to express a constraint problem? Like, you have business constraints that you want to feed into a solver like Solver Foundation or maybe Z3, and you basically want to, or you don't want to learn another language. The language to have constraints and decisions and goals, like we have languages out there that do that kind of stuff. But as a C# user, why can't you write a LINQ query to basically encode that problem? Maybe parameterized so that things can come in from a UI, of course, for sure. But the thing is, like, the syntax is there to do a lot of those things, whether it's based on concrete data or it's abstract data. And the abstract data is like, for example, I want to have a decision that gives me two double values where there is a local optimum for a certain problem. Like what's the lowest cost to get, to purchase some goods based on constraints I have. Like I need to have that many barrels of oil to keep my plant going. And if I order them there, they're that expensive. If I'm ordering them in a different country, they're different expense. Like what's the most optimal way to basically order that thing? And so this is really about like looking at that product of abstract numbers, like in this case, two doubles, like you have two places where you want to order things, and you want to query that infinite times infinite space. You can't even walk the space, it's not enumerable, it's doubles. So like you have to solve it symbolically, but there's nothing preventing you from doing the symbolic manipulation using LINQ expression trees and using the same syntax. And so, as opposed to learning something else.
Absolutely. Excellent. Now we're getting a bunch of questions.
Oh my goodness.
Ow, man, you finally woke up. Welcome. So, does RX have built-in support for performance count as timer? It wouldn't be affected by OS clock change.
Oh yes,
Very useful.
Yeah, definitely. So, so he's actually asking for the query performance counter.
Yep.
Function that's in Windows and query performance frequency, which is actually used by the stopwatch class in System Diagnostics stopwatch. We're actually using that in a number of places now. We didn't before. So whenever we need to simulate time, we actually, like for example, if you do a delay, right, we're basically recording how much time there is between the events. And we do that basically by looking at the stopwatch. So we have the intervals between them. Then when we replay that whole thing, we start a new stopwatch, and based on the offsets in that stopwatch, we actually execute things. And so system clock changes don't interfere with that, indeed, because it's basically just CPU ticks, or well, it's actually based on the hardware that might have different counting hardware available, like, and so yeah, we actually support that fully. Yeah.
Excellent, great question. McCrumple asks, why are queries in space easy and queries in time hard?
Yeah, doing things in space is typically you're in this fixed world where you sort of have all the ingredients on the table, and then you add time to that, and all of a sudden you enter the domain of concurrency as well, because you have things like a timer that runs and it needs to pull things from a sequence, for example. Well, doing all of that stuff implementation-wise is pretty hard.
Sure.
Now, as an end user, it doesn't necessarily need to be hard, but there are subtleties around it. And one of the big problems is like space leaks. Like say you have a sequence that's being produced and you give the sequence to someone to observe it. But the guy who wants to observe it is not tuning into the sequence immediately. And you already have events queued up that you want to deliver to that person. Well, what do? Maybe they will never come in and actually say, I want to receive the values. So you have some kind of conflict there between handing out a sequence and somebody tuning into it where you can lose messages. And so it's all of those kind of interacting with the user that may actually have additional complexities around it. And so that's why you need to be careful about a lot of those things. Yep.
Excellent. Great questions, guys. Al asks, what do you think about task data flow? Do you use it at all inside RX?
So yeah, data flow is one of those new technologies that comes in .NET 4.5. It's based on the TPL and task of T. And it allows you to basically build those data flows using blocks that you chain together. And so inside RX, we don't quite use that. We have something that's close, and I would say the closest aspect in Rx to data flow is composition using subjects, which is a very stateful thing to do. Like you have lots of building blocks there, like subjects where you can feed data in and you can listen to them, and then you start gluing those guys together. That's not the way we do things in Rx. In Rx we say the way we glue things together is using composition of query operators. And so if you're in that functional style of doing things, you basically want to chain things together, just like you have pipelines in Windows PowerShell, for example, that's also chaining things together. You say, I have a source, I do a where, I do a select. Same with LINQ to objects. Now, on the ingress and the egress of the Rx infrastructure, you typically want to use things like subjects, because you want to have an addressable endpoint where people feed things in. And that's also a place where data flow can actually be used. Like on the edges of the Rx network, you can feed things into the Rx pipeline, which is then more like a purely functional kind of construct. It's not purely functional in the sense there are no side effects, but it's functional in the style that you do things, like you chain things together in a very declarative fashion.
Okay.
And so when you go to data flow, you're much more in gluing blocks together. So it has more of an imperative feeling to it. But I think the two actually can coexist totally. By means of like having Rx as the query layer and then have the underlying mechanisms, it's always easy to translate them into iObservable sequences.
Excellent.
Yep.
So let's talk about Connect and Rx, because I know that in your talk,
yes,
you did a nice demo.
Yep.
And I think Connect is a brilliant example of where it makes sense to be able to have LINQ query operators over streams of event data.
Definitely, yes.
So talk to me about what the demo was and take us through it.
Yeah. So the demo basically has the realization that as soon as you walk up to the Connect SDK, you have all the materials in the room to do fancy stuff, right? You have events coming out of it. But the reality is the API is pretty much a wrapper around the native code API. You have lots of little things that you need to be aware of. And so you don't necessarily want to focus on those problems when you want to solve, a gesture recognition problem, for example. So just to set the scene here, for example, there is an event called skeleton frame ready. It basically tells you when skeletons are being tracked, and then you get where the joints are. Where's my hand, where's my head, where's my spine, my knee, and all of those things. And so you can get notifications of those, but the funny thing is when you look at the event arcs don't contain the skeletons. They contain a method that you can call to basically get the skeleton data. That's where sort of like the invoke kind of things happen likely behind the scenes. Now what you get back then is a skeleton frame, which is iDisposable. Now you're already starting to scratch your head at that point. Like, I get the skeleton frame and it's iDisposable. What do I need to do with that? Well, the answer is, in the next 30 milliseconds or so, because there are 30 events a second, you need to fish out that data, process it, and return to your caller. And if you overstay your welcome, bad things are going to happen to the Connect API or whatever, because they already have new data available. Maybe they're overriding the same buffer. So there's a lot of imperative stuff leaking through. Now, as soon as you want to do things like gesture recognition, what you need to do is you need to put those things on a timeline. You already have the ticks when data comes in. But all of a sudden you need to sort of, for example, look at the last second of data. Now what do you need to do at that point? Whenever the data comes in, you need to stash it into some dictionary or in some array that contains the skeletons and the joints. And then you need to do that every time. And then after 1 second you would have to run a timer that basically takes all of those things out of that field where you stored it, and then do some aggregation on top of that to recognize a certain gesture or do some analytics over that. And so all of a sudden that iDisposable thing, for example, becomes very cumbersome because you need to make sure you release those guys early enough. You need to stash them somewhere, you need to run separate timers, you have a lot of imperative code in your callbacks, and things are just spread out all over the place. And so what we did in the demo here with Rx and Connect was actually wrap that .NET event as an iObservable of joints, or an iObservable of joint arrays, that every time I was moving, you basically get the new positions. Now, as soon as you have that, what you can do is you can write very nice queries. You can say, I just want to have an iObservable of the point of the left hand by doing a projection. You say, from joints in the joint collection, that's always changing 30 times a second, I want to select the left hand position, the left hand joint position. So now I have an iObservable of points. Now, when I have the iObservable of points, I can start buffering them in groups of like 1 second worth of data or 5 seconds worth of data. So I can actually analyze what's going on over 5 seconds of hand motions and sort of skip that window forward every second. So you basically get that, data sort of thrown at you, and you can analyze what's going on. So the end result of this demo was actually basically a sequence that said the left hand is being moved. Okay. Like, you have the left hand and you're basically swinging or something, or, like shaking your hands.
Or you're throwing a punch.
Yes, exactly. You're doing a punch here with the robots. Yeah. Well, basically you get an eye observable of notifications whenever that happens. And so doing that using the classic events would be outrageously difficult.
Yes.
Like, lots of fields, lots of timers, and then how do you clean up the mess? Like, are you not leaking any timers? And like, when you do that composition using RX, it's literally just a bunch of LINQ queries. It fits on like 20 lines of code.
Nice.
And you basically just do a from and a where and a select and some other from and some buffer operation, and it's even not 20 lines.
Awesome.
There's some white space in there as well.
So we're going to have Clint implement this, because of course Clint and company, the Coding for Fun people, wrote the software that powers the robots over there, which are Connect driven.
Yes.
But they're not using RX. So
okay, well, we should talk.
We'll have to bring you over and kind of school Clint, man.
Okay, definitely.
All right, so McCrumple asks, we sort of already just talked about how you'd go about detecting a Connect kick with RX.
Yeah.
Basically what you just said, but instead of looking at the left hand, you look for the leg.
Yes, you would look for the leg, and you would basically do something like collecting a chunk of time in which you have events, and then you run some typical function in Euclidean space or whatever to notice whether the leg has moved significantly based on like Euclidean distance or something, or whatever you see fit there.
Okay.
But like sort of aggregating that data together and then having a helper function allows really functional composition, where you say like, I want to have the stream, I want to buffer it up in chunks of a number of seconds, and then basically detect when certain things happen that are of interest.
Excellent. So you mentioned functional composition. Why is that so important? I mean, what do you mean exactly?
Yeah.
For people who aren't functional programmers.
Yeah. So it's really like, one way to think about it as a LINQ developer, right, is the whole thing you have with chaining things together. And the chaining things together is really some sweet sugar on top of like reverting the order of the parameters in calls, because typically they are extension methods, right? Like you get that fluency by means of extension methods, but really what's happening is you're doing something like a select of a where of something with functions that you pass in. And so in that whole composition, you don't really have any state that you have to keep yourself. Like, it's all hidden in those operators. There's still state going on. Like, for example, if you do a take 5, we have to count somewhere, but it's not in your face. You're basically gluing together the building blocks, the Lego blocks that we basically gave you. And so it's as simple as just dotting into things and basically passing in functions, little helper functions. Like, where is an empty box that knows how to filter if you give it a function that tells you how to judge whether an element belongs in the output sequence, yes or no. And so you basically chain all those things together. You give the appropriate functions, which are like little holes in the implementation that you have to fill in. And so it's a very generic world, it's a very fluent world, and all the state management, especially in RX, is all hidden behind the scenes. Because in RX you have those timers, and that relates back to a question we had before. What makes it so hard to do time? It's like dealing with state in the face of concurrency. Because you have timers, you have multiple sequences that may fire at the same time. Like, you have to have your locking right, or your volatile fields and all of those things. Like, state may not be a big problem if you're doing console read line, console write line kind of things. But as soon as you add concurrency to the mix and you add like, a lot of stateful operators there, like, boy, it sort of goes out of this room, right?
That kind of leads to the question, I mean, how do you manage state in the RX world? I mean, the state monad?
Not quite.
So let's talk about that.
So basically, like, the way to think about RX is really, as you build your query pipeline, nothing happens, right? You're basically just chaining together the ability to run something. Saying, I have an event sequence, I want to sample it. Nothing's happening yet because we're not listening to the sequence. So we're basically chaining all of those things together, and then you have an eye observable as the outcome. And then when you subscribe to that thing, really your intent, that's basically an observable sequence that sort of knows it has to do a where and a select and this and that, basically turns into a chain of observers, right? So there's an observer that listens to the source and will do some filtering. Filtering is a pretty stateless thing. It just has to run a function, right? And as soon as you have things like sampling, we have to stash that state somewhere. And so what's really going on is that chain of observers, each observer has its own private state. Okay. So for example, the sampler knows the last time somebody wrote to the sequence as well as the value that was actually written. And then when the timer comes, it fishes out that value and resets, the fact whether there was already a value seen in the previous interval, because we need to restart, right? So the sampler basically fishes things out and does that in a thread-safe way. Like it has to put a lock around there because the timer may fire at the point the sequence fires. Sure. So we need to make sure there's nothing going haywire there. But the secret recipe there is that the state is sort of not spreading around. Like if you would do all of those things like sampling, throttling, things like distinct, like you would do all those things yourself, what you end up with is a class with an event handler, a timer tick callback somewhere, and then a bunch of private fields. Some that have to do with the dictionary for the distinct operator, some that have to do with the sampling state, and you have really hundreds of fields sitting there that all have to cooperate in some way, and some of them are basically mutually exclusive in terms when they can happen. So you will likely have like 15 gate objects that you will lock over, because otherwise you take big locks. So what's happening in Rx is that each individual observer has the state it cares about and nothing more. And so that's basically the direct result of doing this functional composition.
Excellent.
Yep.
That's a great way.
It's putting things under the carpets.
Absolutely, man.
Out of the
out
vision
of the way,
of the user.
but you're guaranteed functional composition all the way down.
Yes, exactly. Yep.
So Al, you know what, Al? You ask this question every time we do Channel 9 Live with Bart to Smet or Eric Meyer. And the answer to the question is exactly the same as it always is.
It's still the same, yeah.
It's not. And the one question I would ask is why does it matter?
Yeah, so the question is like...
I'm sorry, what's the question? So
the question is, will Rx make it into the BCL, or will some libraries go there? The answer is there are a couple of aspects to this question, right? First of all, the trend we're seeing with the framework is that more things are basically being modularized, right?
Yes.
Like we see that everywhere. Like when you listen to, like, for example, Jeffrey Snover talk about Windows Server Core, it's about a layered cake diagram with the core capabilities and things on top of that. The same thing happens in the library space, right? We had the .NET framework, it grew, and at some point we said, well, the deployment footprint has to go down. And I actually was involved with the original effort in 3.5 SP1, where we did a client profile. And so that basically sort of split up the framework into different pieces and put more things around it. Now, we're seeing that happening more and more with new libraries like Entity Framework. Well, they have a copy in the BCL, but they have also the fast cadence of shipping things.
Exactly.
So they put things on NuGet, and that will also happen with new additions to the framework, actually. They will not be in the core, but they will be available separate components.
Sure.
Now, an interesting question is, why do people ask the question, right?
Yeah, why?
And so one of the things we've seen is like people sometimes are concerned about supportability. Because they have the .NET framework, and the .NET framework comes with a certain EULA that says you can rely on support. There's nothing preventing us to have support for the things that we have on NuGet. And so that's exactly the same with Rx. You can call up to PSS or CSS or whatever they call it now, and basically ask questions about Rx.
Sure.
So that's one of the aspects. The second thing is we're sort of shifting towards a world of more app stores, right? Where you basically have the components deployed to the app store.
Yes.
And so what you do there is you basically compose your application. You rely on some things that are on every system installed, but you tend to suck in much more individual libraries because the deployment aspect is sort of friction-free for you.
Yes.
It's somebody else taking care of it, namely the guy who actually owns the store. So the dynamics are also changing a little bit there, because if there are a lot of applications in a store that all use the same library, maybe
why are
it
they
makes
all
sense.
Uploading it?
Yeah, exactly. Why wouldn't it make sense to basically have shared copies of that? And so we may see in the future that there's lots of those libraries that actually are becoming common, based on telemetry data of, for example, the stores, and then we could go and sort of put things down.
But I think going back to your original point, and we have to wrap up in just a couple minutes.
Yeah, sure.
Serviceability is an issue, though. I mean, if you want to go the route where you get this big drop that happens every couple of years or a year and a half or wherever, or you want to be able to play around with Bart's latest creation in some alpha version of RX 3.0 or whatever, an experimental build, you can do that. Now, I wouldn't ship with an experimental build, obviously, but my point is, plus you could also have an ecosystem where different versions of RX are shipping in the same store.
Yes, exactly. Yes, so, totally.
So anyway, love that you're asking questions, Al. The answer is no. Doesn't matter.
Not at this point.
Hey, thank you for coming on.
It's always a pleasure.
Always a pleasure to see you, man.
Thanks very much.
And enjoy Belgium and your user group, and welcome home, man.
Okay. Thank you.
Cheers.
See you.